All right, so what's the first step here? I'm going to group those first two terms together, and then I'm going to take out that -2. So the -2 is going to come out on the front. I'm dividing both of these terms by -2. So it goes away from the x squared, but it affects that +3 as well. This becomes -3/2 x. I'm going to leave the space because I need to fill it. I'm going to put the 5 on the outside. Then what?
Then you're going to take the -3/2 out, divide it by 2, and square root it.
Good. So 3/2 divided by 2 squared, or 3/2 times 1/2 squared, would be 3/4, and that squared is 9/16. So that's what I'm adding inside the parentheses. And I would normally be subtracting it from outside the parentheses. But because I took something out, I have to multiply it by that first. When I multiply -2 times -9/16, first of all, it becomes positive. And then 2 goes into 16 8 times. So I'm adding 9/8. With me so far? Yes?
I see multiplying the -2 by the 9/10.
Correct. Whatever you're adding to or subtracting from the end, you have to multiply by what you took out. So now the -2 stays. I'm going to factor this. Factor by square rooting the x squared, you get x. Square rooting 9/16, you get 3/4. If it's hard for you to square root from here, go back to before you squared it over here. You already have that number. Take the sign from the middle, which would be negative. Put it in the parentheses. Don't forget to square it. And then I have to add +5 and +9/8. 5 over 1 becomes 48 plus 9/8, or 49/8. This whole thing is my standard form. What's the vertex?
+3/4, 49/8.
Good. What's your axis of symmetry?
+3/4.
Good. X equals 3/4. What do you know about the shape of this parabola? What direction does it point? Down. And that -2 on the front would have what impact? Good. It's a vertical stretcher. It's going to make it more narrow. So just from that alone, I would know 3/4. I'm going to go to the right 3/4, which is obviously not all the way to 1. And then 49/8 is 6 and 1/8. So I'm going to go up 1, 2, 3, 4, 5, 6 and 1/8. And I would plot my point. And we said it's going to point down. So it would cross through my x-axis. I'm not going to find them, but there are 2 x-intercepts. And there is a y-intercept. Okay, that you know already. So your quiz is going to ask you to take an equation and put it in standard form just like that. And then today we're going to learn another method that you could choose between on one question. So one question is going to say, put it in standard form. It's going to force you to complete the square. But then by the time test comes around, you have a choice. And then on the other question, you have a choice of using the other method, which is that -b over 2a. Questions before we get into it? Okay, we're going to continue on with the notes from 2-1. Yesterday, we did what if it's already in standard form. We talked about the axis symmetry. We talked about all this stuff. And then we did what do you do if it's not in standard form? You can force it into it, which was complete the square. You can also go this approach. So if you are graphing it without putting it in standard form, so not completing the square, and it's in quadratic, meaning ax squared plus bx plus c, so you have an x squared and an x, then you can find the vertex by doing -b over 2a. The h coordinate of your vertex would be -b over 2a, and that's going to be the x coordinate of your vertex. And then you plug that back in to get the k. So I would do f of h. Whatever I get for h, I'm going to plug back in the x God bless you. And then solve, and I'll get the K. So then I cannot use shifts to graph that. Based on this process, you'd have to plot your vertex. You can, from there, find your axis of symmetry because it's still x equals h. You can find your intercepts by plugging in 0 for x and plugging in 0 for y. If it's factorable, we could do it from here. I don't have to put it in a standard form. So if it's factorable, I'll try to factor it and find my intercepts. If it's not, your backup is the quadratic formula, okay? And then find your y-intercept, plot that. If it's enough information, you're done. If it's not, you're going to plot in some extra points. So we call this negative b over 2a, but basically you're finding it without putting it in standard form. All right. So notice this is the same question we already did. We know the answer to this, but we're not going to do it using that method. We're going to use negative b over 2a. So again, I know to do it because it's an x squared and an x. It's not in standard form. What's the a here? Negative 1. It's what's in front of the x squared, right? What's the b? Negative 3. It's what's in front of the x. So if I wanted to find the x coordinate of my vertex, or h, I do negative b over 2a. So negative 3 over 2 times negative 1, and I get 3 over negative 2. That's the x coordinate of the vertex. With me so far? Now I got to plug that back in. So I'm going to plug that back into each of the x values here. I get negative, it goes in parentheses, so negative 3 halves squared minus 3 times negative 3 halves plus 7. And this is going to equal the y, specifically k, the y coordinate of your vertex. I take care of my exponent first, so negative 3 halves times negative 3 halves is positive 9/4, but that negative is still on the front. I can multiply out negative 3 over 1 and negative 3 over 2, and I get positive 9 halves plus 7. That negative on the front makes this negative 9/4. I'm going to have to change them so they all have the same denominator. So I'd have to multiply by 2 here and here. I'd get 18/4. And I'd have to multiply by 4 here and here, 28/4. And then I get negative 9 plus 18, which is positive 9, plus 28 is positive 37 over 4. Now, if you look back on what we did yesterday, we did it using complete the square, but we ended up with the same answer, negative 3 halves and 37/4. From here, you can get your axis of symmetry, which is x equals negative 3 halves. And again, if I needed to graph this, I could. I would graph it. I would find my intercepts. This one is not factorable, so my intercepts would have to be found using the quadratic formula, okay? But I would approximate it first. I would say, okay, this is negative, which means it points down. I would plot my point and see if it even crosses the x-axis. If it doesn't cross the x-axis, I'm going to save myself the time of not using the quadratic formula to find it. You remember your quadratic formula? Negative b plus and minus the square root of b squared minus 4 times a times c all over 2 times a. So if my equation is not factorable, if negative x squared minus 3x plus 7 is not factorable, which it's not, there's no factors of negative 7 that sum to negative 3, okay? Then I would do a is negative 1, b is negative 3, and c is 7. And I would plug it into that quadratic formula. If we have time at the end, I'll come back to this and we'll work this all the way through. But that is your backup to being able to be factored. Obviously, check to see if it's factorable first. It's going to be faster. But if it's not factorable, then quadratic formula is where you got to go. Max and min. Now, this is an absolute max and min. There are not more than one answer here, okay? It is either pointing up. So if my A is positive, it is pointing up. There is a minimum value, and the K is the value we give for the minimum. So not a coordinate point anymore. The actual K value is the lowest point on this graph. So that's the minimum. If my A is negative, then this opens downward, and the K is the maximum point here. So we give that, okay? It doesn't matter if it opens up or down. The K value is what you give. The difference is it a max or is it a min? All right, example 6 says identify the vertex, the x-intercepts, and then use a graphing utility to verify. So instead of doing complete the square, which you could complete the square in this sucker, okay? We're going to practice negative b over 2a. So to find the vertex, I start with h being negative b over 2a. What's a? Negative 3. What's b? Positive 2. So negative 2 over 2 times negative 3 is positive 1/3. You could either multiply it out and get 2/6, negative 2/6, or you can simplify it either way. This goes here. It's positive 1/3. That's the x coordinate of my vertex. To find the y, I'm going to plug it back in. So I'm going to do negative 3 times 1/3 squared plus 2 times 1/3 plus 5. What's 1/3 squared? Good. Plus 2/3 plus 5. And then 3 actually goes into 9 here. I can simplify this. It would be negative 1/3 plus 2/3, and 5 over 1 becomes 15/3. Negative 1 plus 2 is positive 1, plus 15 is 16 over 3. That's the vertex. Axis symmetry would be x equals 1/3. It doesn't ask for it, but it would be x equals 1/3. Now it asks for the intercepts, okay? Do the easy one first. How do I find the y-intercept? Make 0x. So what happens if this is 0 and this is 0? It's just 5. So my y-intercept is easiest from quadratic form. It is literally the c. 0, comma, c. Now think about where 1/3 and 16/3 is. 1/3, 16/3 is 5 and 1/3. It's up here somewhere. And which direction is this parabola pointing? Down. So it is in across the x-axis. There should be x-intercepts. If it was pointing up, then when I go to find the intercepts, I shouldn't be able to find them, okay? So now we see if this is factorable. Negative 3x squared plus 2x plus 5. There's two methods here, either trial and error or what most of us pick, first and last. If there's a number on the front, we do first and last. So negative 3 times positive 5 is negative 15. And then I'm looking for factors of negative 15 that sum to 2. Are there? What are they? Good. Negative 3, positive 5. Then I replace the middle term with those two. And then there's 4 terms, so we factor by grouping. From the first set of parentheses, I can take out a negative 3x, and I get x plus 1. Second set of parentheses, I could take out a positive 5, and I get x plus 1. And then the x plus 1 is your greatest common factor, so that's coming out. And the negative 3x and positive 5 get grouped together. Now I need to solve these. So I split and solve here. I set them each equal to 0. And I get x equals -1. Negative 3x equals -5. X equals positive 5/3. And if I had graphed that, -1 would be left of my y-axis. 5/3 is 1 2/3. So right, and then I'd make my parabola. Yep. Intercepts you given coordinate point form. So the things you list are zeros or solutions, like which will when we get into 2, you'll see that. Intercepts you're going to put in coordinate point form. Okay, then it says you verify using a graphing utility. So we're going to put this into our graphing calculator. All right, so first of all, I typed in the equation. Negative, remember it starts with that negative. It has to be the special little button. This guy, it can't be the minus. Negative 3x squared plus 2x plus 5. And then I'm going to hit graph. Oh, my window's not square. Let me just adjust that. Okay, yours should look something like this. Okay, which is consistent with what we drew. It would be consistent with a 1/3, 16/3, and then my intercepts at -1 and 1 2/3. How we check to be sure is, what's the point called at the top? It's the max this time. So I'm going to go left of it. It's already left of it. I'm going to go right of it. And I'm going to hit enter, and it's going to bring you to the top. Now, this is in, obviously, decimal form. 0.33 is 1/3, and 5.33 is 16/3, because that'd be 5 1/3, okay? Matches what we did. If I wanted to check the intercepts, second trace, I go to my zeros. I go left of the first one, right of it, hit enter, and that's at -1. Repeat that again, second trace, 0, left of it, oops, nope, I hit it twice. Left of it, right of it, 0. And it's 1.6 or 1 2/3. Questions? Okay. This is all that. So like it basically just tells you what we just did. If you're ever confused, you don't remember how to do it, you come back here. This is your little cheat sheet, okay? That's the min, the max, and then the zeros. All right. Now we're going to reverse it. What if I give you the information and I ask you for the equation? That's this one, okay? So you're going to take your, I'm going to give you the vertex and a point. You're going to take the vertex, make that HK. You're going to take the point, make that XY. You're going to plug it into the standard form of your equation, which is y equals a x minus h squared plus k. You're going to plug in the h, you're going to plug in the k, you're going to plug in the x, you're going to plug in the y, and you're going to have the only thing left, which is a. You'll solve for a, and then you'll plug back in the a, the h, and the k. So in the end, your y should be a y, the a is going to be a number, the x should be the x, the h should be a number, and the k should be a number, okay? It could be plus or minus, but it has to have the actual y and x should be there, and the squared has to happen. So a lot of people, when they do this, they make the mistake of forgetting the square. Don't forget the square. All right, and they'll look like this. Find the equation of the parabola in standard form, then graph the parabola and identify the max and min. So make sure you identify which one's the vertex and which one's the point, because if you switch those up, it messes it up, okay? The vertex is your HK, the point is your XY. So y equals a, x minus h squared plus k. Write it as many times as you need to till it's stuck in your brain. The y is 15. The a is what I don't know. The x is 7. The h is 5. And the k is 12. With me so far? Okay, then I'm going to take care of the parentheses because that would be first. This would be 2 squared plus 12. This is 15 equals A times 4 plus 12. And then do I add the 4 and 12? No, don't do that. Okay, that's multiplication and addition. Those are two separate things. So I'm going to subtract the 12. And I get 3 equals A times 4. And I'm going to divide by 4. And my A is a positive 3/4. If it's supposed to be negative, it will end up negative. You don't have to worry about changing your sign. Now I'm going to plug back in the A, the H, the K. So I get Y equals 3/4 X minus my H, which is 5, squared. Don't forget to square it. Plus K, which is 12. And that's the standard form of this parabola. I don't care if you put y or f of x. It doesn't matter. They're the same. So what's the maximum of this? Or max min? How do I know if there's a max or a min?
If the A is above or less than 0.
Good. So A is positive, which means?
It's the max.
It opens. Oh, so close. If it's positive, it opens up, which means there's a minimum value. And what's that minimum value?
3/4.
Nope. 12. Your K. Okay, it is your K. Careful, it is not your C. So if this is in standard form, it is not just C. It is your K. It has to be, I'm sorry, if it's in quadratic form, you can't pull the C. If it's in standard form, that's where you identify the K. If I wanted to graph it, we'll just do it kind of quickly. My vertex would be positive 5, positive 12. I did not go up enough. Okay, something like, here, let me erase this. Didn't give myself enough space. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, and it would point up and it would be wide-ish, okay, which would be consistent with a 7, 15, because that's where the point on the curve should go. There would be no x-intercepts this time. If I went to solve this, I would get an imaginary number. I would get a negative under my square root, which would give me an imaginary number. There is a y-intercept, yeah. You'd have to plug 0 in for x because you're not in quadratic form. But if you plug 0 in for x, you get what? Negative 5 squared. 25 times 3/4 plus 12 would be your y-intercept. Yeah. Yeah. The K is always the max or min. It just depends. Is it the max or is it the min? Yep. Okay, last one, and we're back to our calculators. This is like what standardized tests eat up. Okay. You're finding an equation that is quadratic. So this one says the height, y, in feet of a punted football is approximated by that big ugly formula, where x is the horizontal distance in feet from where the football is punted. Use a graphing utility to graph the path of the football. How high is the football when it's punted? What's the maximum height of the football, and how far from the punter does the football strike the ground? All right, so let's enter that sucker into your calculator. Yep. Okay, and I'll give you a couple tips. One, it's okay, fraction? Yeah, so if that's where I'm going next. Good segue, Hayden. If you're that lucky little person that has, like when you hit, I'm going to clear this out first of all. When you hit alpha, x, t, theta, n, if you hit that, if you're a lucky person, you get a fraction. I don't, okay? I'm not one of those lucky people. But if you hit alpha, green button, x, t, theta, you could pop a little box up there. That's your fraction, which would be fantastic, okay? Good for you. That's not me. So then your other option is literally type that in parentheses. It would be negative 16 divided by 2025. Put it in parentheses. I didn't put it in parentheses. The negative could be in the front of the negative 16 or after. It doesn't matter. Or the other way you get the fraction is you go to math and you arrow over to where it says FARC. And you hit enter on the n/d. That's your numerator denominator. You can also get it that way. So I did 16 over 20, 25. Now I have to put the negative in the front here. And not the minus, but the negative. X squared plus, I could do the fraction again, math. Oh, I put the, hang on. It is supposed to be a parabola. Yeah, if it's not a parabola, something's wrong. Well, think about what's happening. Hang on. Plus math 9/5 x plus, I'm just going to do the, all right, so big curve happening here, right? We know this has to be a parabola, right? So what's one way to get that full parabola in my, I can zoom out, so I can hit zoom, and I can zoom out, and I hit enter, and I get a little more. You could do it. What happens? Still not making it, so you could zoom out again. Is it your negative?
Oh, does it have to go outside the?
No, but it has to be the negative, not the minus.
Does the x squared have to go outside?
No. The squared can't go outside the parentheses with the x inside. The squared has to go on the x. Hang on. I'll show you in a second. Okay. I'm going to do it one more time. Zoom out. All right. So this is also, I would say, one of the questions that your graphing utility app is going to be easier because you could literally pinch until you see it. Okay. If I give you a question like this, these numbers are not going to be this hard. You might have to zoom out once or twice, but you're not going to, like that had to zoom out 3 times to get that full curve. Okay. I'm not going to torture you that bad. But if it's on a homework question, this is when the benefit of the app is you literally can just pinch until you get that whole thing. So now let's think about what we need from this graph. Okay, A is use the graphing utility. B, how high is the football when it's punted? What question is that? What part of my graph is it where it's punted? The y-intercept. If you ever see, maybe if you've never seen a punter, they literally don't kick it off the ground, right? They drop the ball, then they kick it. So it's not off the ground. This isn't a kickoff. This is a punt. So the y-intercept would be where it starts, okay? I don't even need the graph to get that though, right? Because this is in quadratic form. So my answer is 1.5 feet. That's from my equation. I don't even need it. But if I do look at my graph, I'm looking at my y-intercept. C says, what's the maximum height? How do I get that? That's the K, so I go to the max. I'm going to trace the top of my graph, and I'm going to find that the maximum point occurs at 113.9 and 104.0. And we said it's the K. That's the maximum height, 104 feet, 104 feet. D says, how far from the punter does the football strike the ground? What does that look like on your graph? How would I know when it hits the ground? The x-intercept or the 0, and not the one before him, right? Because this actually doesn't exist in real life. It doesn't go backwards. It goes forward, hopefully. It goes forwards, and that is 228.6 feet. I did the 0 on the calculator. So second trace, 0. But you have to